Time for a look at the local preference attribute. We're going to talk about the theory of it for just a moment and then see it live on a totally different topology than in previous labs. And I do recommend you write this one out when you can see the whole thing. It's a bit of a tease right now. I'm just showing you half of it. But I want you to concentrate on this little bit of theory first, also known as local underscore pref sometimes, and also we saw it as lot perf in show IP BGP. This is a well-known BGP attribute that also comes into play when multiple paths between ASs exist, just like the MED, except it's totally different. Because the local pref attribute, it's just that, it's local. And where the MED tells routers outside the AS which entrance path is preferred, local preference tells routers inside the local AS which exit path to use when multiple paths to a given destination exist. I know, it's like stirring concrete with your eyelashes the first time that you read that. And I stole that from Scott Turow, 1L. But the path with the highest local preference is preferred, and this will become crystal clear to you as soon as we do a lab with it. The most important thing to remember about the local pref is that it is passed only between internal peers. That's where the I and the E come in again. They're passed only between your IBGP peers, and local pref is never advertised outside the local autonomous system. So that dreaded phrase from your frame relay CCNA studies, locally significant only. That's exactly what the local pref attribute is. We're going to tweak that a little bit here in our next lab, and something a bit different here. All four routers are on the same segment, 10110/24, and all adjacencies are formed using addresses from that segment. So you might want to write this one out. And nothing tricky here at all. I already have the adjacencies in place. And what I've also done is put a link between routers 3 and 4, a direct link, 172.12.34.0/24. We're not using that for adjacencies, and that's why I'm not showing it in this diagram, but that is the one that we're advertising into BGP to give us a local pref. Otherwise, if we have no routes, we have no local pref. So nothing tricky with the configs here, and you can see again routers 3 and 4, that network is 172.12.34.0, and I already have that advertised. Now routers 1 and 2 should both have two paths to that network in their BGP tables, and let's have a look right now with show IP BGP. I already ran that for you too, and router 1, that is router 1 up at the top, and you can see router 1 has two entries for 172.12.34.0, and it's chosen the valid and best path as the one with the next hop, 10.1.1.3. Makes sense. Router 2 is, well, it has the same entries, 172.12.34.0. It has two entries for it, same two next hops, but it has chosen 10.1.1.4 as the next hop. That's the path it's going to use to reach 172.12.34. Again, makes perfect sense. Router 1's going through router 3, and router 2's going through router 4. And going back to the diagram for just a moment, again, with all things being equal, that makes perfect sense. But of course, we're going to mess with it a little bit because we want to see this local pref in action. And something I'm going to point out to you a couple of times here with show IP BGP. Now, we have a metric of 0 listed for these. And before we didn't have that. That's because I had the MED on there, of course, in the previous video. Then I removed all of that, but we're still showing a 0. So nothing totally unusual there, but local preference is what I want to really point out to you right now. Note that you only see local preference for one of the two paths on each router. So does that mean the local preference for the other path is 0? We're going to see here in just a moment. And let's go ahead. I want to bring the board back up for just a moment. And actually, I do mention it here, so let's go ahead and talk about that before we start working with the local preference. Viewing local preferences with show IP BGP can be really misleading. And let's concentrate on router 2 right now here at the bottom. We see a local preference for the path that is considered valid but not best. The local preference is 100. Let's go straight across. But then the path that was chosen as valid and best, the local pref isn't shown. So does that mean, again, I know I'm asking the second time, does it have a local preference of 0? Well, let's run show IP BGP 172.12.34.0 and see. And no, it doesn't mean that. It's just not showing. You always want to run show IP BGP with the full network number when you're checking the local preferences. Personally, I run it every single time. I just like to see all the information. And of course, earlier in an earlier video, when we saw inaccessible, this is the fastest way to see it. There's nothing wrong with running show IP BGP, but I always take a few extra seconds in a lab or production network, what have you, to run show IP BGP and then put the network number in. It just gives you a little more information. So right now we see that the local preferences are actually the same, and router 2 we see the path selection, and the next hop is 10.1.1.4. But what if we want to change that now? Well, we have a couple of different ways to do that. And as we know here on the board at the top, the local preference for both routes on R2 is 100. So if we raise the local pref on router 2 for the path with the next hop of 10.1.1.3, that should change the route selection. Now we have two choices when it comes to changing the local preference. We can change the local preference for all routes advertised by a given router, or we can change the local pref of a particular route, not router, and I'll change that. We're going to look at the all or nothing approach first. We know the route for 172.12.34 with the next hop of 10.1.1.3 is coming from router 1. So if we're changing the local preference in this fashion, we're going to do it over on router 1, not on router 2. And we use the command BGP default local pref. Let's go back over to router 1. And it's router BGP 12. When you change numbers every video, it's like, okay, which one is it? Let's do BGP. We've got quite a few commands here that we haven't looked at too much. And default is the one we want, and local preference. And we even get a handy reminder from the router there, higher equals more preferred. I like that. And I wouldn't go up to 42 gajillion or whatever that is. Let's just go with 200 here. And we're going to do a soft reset. And then hop over to router 2. And you can see now the local preference has changed for the route that's coming in from router 1, and the route selection itself has changed. 172.12.34 router 2 is now using the path through router 1 and then down to router 3 with the next hop of 10.1.1.3 as its valid and best. And the reason is because of that higher local preference. And it never hurts to verify everything or just have another look with 172.12.34.0 with show IP BGP followed by the full network number. And you can see, of course, this one has been named best now. And that's the reason right there, local pref 200, while the other local pref, the route coming in from router 4, stays at its default of 100. Nothing wrong with this, but the one thing that probably leapt to your mind when we started doing it is, do we really want to change the local pref on all routes being advertised by router 1? In this situation, it didn't hurt anything. There were no side effects, so to speak. Well, what if router 1 had other routers it was advertising to? What if router 1 had 20 routes that it was advertising over here to router 2, and we just wanted to change the local preference for a few of them? That's the more likely scenario in a real-world networking situation, and actually in a lab situation as well. So coming up next, I'm going to show you how to use a route map to change the local pref on some routes, but not all routes.